Hello and welcome to this week's Solution Saturday. In this series, we'll be focusing on the more difficult questions from the North London Independent Girls' Schools Consortium Group 1 2017 paper. In this video, we'll be going through the solution for question 38 step by step, and hopefully you can see how you can utilise the techniques you've already learnt in class to solve the problem. If you have any questions, then don't hesitate to ping us on Facebook, Instagram, or in the comments section down below. Consider this question. The 57 pupils in years 5 and 6 were asked about their favourite crisps. The table below shows the results. In the first section of the question, we're asked to complete the table. The easiest way to go about this is to identify a row or a column in the table where there is only one piece of missing data. We can identify this here and here. Let's start off with this row. We can see that there are 25 students in Year 5 in total, and of those 25 students, 12 of them chose cheese and onion. The missing piece of data here is the number of students who preferred salt and vinegar. We know that the data for the total number of students is the sum of those who chose cheese and onion and those who chose salt and vinegar. Therefore, to calculate the number of students in Year 5 who chose salt and vinegar, all we need to do is subtract 12 from 25. Which gives us 13 students. Now let's move on to this column. We have the data for the total number of students overall, as well as the total number of students in Year 5. In order to calculate the total number of students in Year 6, all we need to do is subtract 25 from 57 to give us 32. By filling in these pieces of information, we have created more single data gaps, and everything else falls into place. Let's take this row for example. Similarly to the first row we looked at, we have the data for the total number of students in Year 6 and those who chose salt and vinegar. We can go about this in the same way as the previous one, by subtracting 14 from 32 to give us 18. By filling that in, we can now calculate the total number of students who chose cheese and onion, which is simply the sum of 12 and 18, which is 30. Similarly, we can calculate the total number of students who chose salt and vinegar, which is the sum of 13 and 14, which is 27. We can do a quick check in the last row just to make sure everything adds up. 27 plus 30 is 57. There are no contradictions in our numbers, meaning that we have the correct answers. Now moving on to part 2. The second part is asking what percentage of pupils in Year 5 like cheese and onion. We can see here that some of the words in the question overlap with those in our table. This will help us extract the data. If you can recall, 12 pupils in Year 5 preferred cheese and onion, and there are 25 pupils in Year 5 in total. We can start off by expressing this as a fraction. We can't stop there, however, as in the question it's asking for us to express the final answer as a percentage. As you may remember from class, there are several ways of converting a fraction into a percentage. In this case, the denominator is a factor of 100. Therefore, we can multiply both the numerator and the denominator by 4. This gives us 100 on the denominator and 48 on the numerator. The reason we do this is because a percentage is just a part of a number expressed out of 100. So now we can see that 48% of the pupils in Year 5 like cheese and onion. Now for the final part of the question. What fraction of all the pupils like salt and vinegar? Write your answer in its lowest terms, or simplest form. This time, instead of a percentage, we are being asked to express our final answer in fraction form. Again, we need to extract data from our table. Our denominator will be the total number of students overall, which is 57, and our numerator will be the total number of students who like salt and vinegar, which is 27. So our fraction is 27 over 57, but this needs to be given in its simplest form. As we've mentioned in class, fractions always need to be expressed in their simplest form. In order to simplify a fraction, you must divide the numerator and the denominator by their highest common factor. In this case, this is 3. We know this because the sum of the digits in the numbers are a multiple of 3, meaning that our final fraction is 9 over 19. We know that 19 is a prime number, and so the fraction cannot be simplified further. Thank you for watching. We hope you've been able to build on your knowledge of how to approach data problems, as well as percentages and fractions. If you have any questions, don't hesitate to leave a comment or reach out on our other platforms. Check out the other videos in the playlist for more solutions on tricky questions from this paper.